How does all this equipment in the central office, from the switch to various networking components, receive their power? Well, it's not AC power they're running on. All this equipment you see here is running on DC power. The same DC power that's powering your laptop or your tablet as you're watching this right now. But it doesn't plug into a wall and then convert it using that little brick that you have there. All this wiring up there, which is the power, is running DC directly to the equipment itself. And that's what we're going to talk about today. How does all this equipment get its power from the DC power system? Let's go ahead and check it out. And to start, we're going to go to the power room where the commercial power enters the building. So let's go take a look. We're looking at our power panel here. You see here we have the 3 lights indicating the phases that are live right now. And if we go to this little guy, this is the plant exerciser. So this allows it to exercise the generator and things like that. Moving down, we have the controllers for the generator. So right here, this is the transfer switch. This states that it's in normal mode, so it's an automatic. When the power goes out, it'll automatically switch to the generator. This is a power failure simulator. They turn this to test to simulate a power failure instead of having to throw the breaker in this thing. And that'll cause the generator to start up and the switch to transfer. The manual close switch allows operation of the transfer switch. If the automatic transfer part of it were to fail, you can close it back to normal commercial power or to alternate power without having to actually remove the panel and operate it manually with potentially lethal voltages. And then down here we have some more indicators saying that we have normals available and normals closed. So that means that commercial power is available and we're on commercial power. And this would be, the generator is running and we're on generator, but since we're not, it's off right now. And then down here is our manual transfer switch, stating that it's currently set to the automatic switch. If, like I said, we lost main AC power, we could switch it to a alternate generator outside. But that would be our power panel here. This is for the AC. And we come to this guy. Here is our breaker. It's an 800 amp breaker. And you can see why you would want to operate that thing manually to simulate a power failure. There is a pretty large arc flash on this thing, and you would have to wear the correct calorie suit and protection and gloves and all that stuff to switch these types of breakers. In our larger COs, we actually have air breakers where you pump the air, like in Jurassic Park. If you've ever seen that, those do exist. They're made by Siemens and probably other companies, where you pump the power for the spring, hit the switch, and it closes it. Coming over here is our breakers. This is a smaller CO, so not that big. We have our main breaker down here, and then it goes up to the smaller breakers for lighting and things like that. And then what this will actually feed eventually is the rectifiers inside the central office itself, which we're going to go ahead and take a look at. And that is what powers the DC side of things. Also down here, that buzzing you hear is the transformer that's made just for this building here. So let's go ahead and take a look at the central office itself. This is the controller. This is a Galaxy Millennium made by General Electric. And right now it's showing us that we're floating at 52.79 volts negative, and it's producing about 867 amps of current out. But that controller that we just showed you actually powers the rectifiers here. Now these are the actual rectifiers that take care of the conversion from AC to DC. And I'll show you the back of these in a second. It shows you right now that they're supplying about 52 volts, and the output current here is let's say 170, 180 amps. And there is 4 of them here. I believe 3 of them are turned down, so it's just one that's operating right now. The rest have been turned down due to the load being not as much in this plant anymore. And here's the back side of those ones here. So we have 1, 2, 3. So there's 3 more rectifiers here that are supplying the rest of the current for the plant. Here is the back of that controller, so that's the controller itself. And then you see all the copper, that's all the buses. And then down there are the circuit breakers. And these are the various circuit breakers for the DC side of things. Now these themselves don't produce power for the equipment. What these do is this sends power to the breaker distribution fuse boards that we'll show you in a second also. So these are just the circuit breakers for the actual distribution boards, or circuit panels, I guess if you want, down the line. And if you notice, since this is DC, we do have these capacitor pre-charge buttons here. What this allows it to do is to charge the capacitors slowly instead of dumping a ton of inrush current into them, which could damage the components further down the line. And as the backup for this plant, these are the batteries. There are, what, 1, 2, 3, 4 strings on that side, 4 strings on this side, each carrying 24 batteries. Each battery is 2 volts, so 24 times 2 is 48. That's where we get the 48 volts for the plant. So what happens is if we lose power to this building, then the equipment stays running, it never shuts down, just because the batteries take over and fill in that gap between the generator starting and transferring over and the commercial power taking over. So with the DC plant, the equipment never loses power. It's always going to have power somehow. That is why, like, the old telephones always had power, because there was batteries here. So now we come down to the actual distribution circuit panel. And this is taking the power from one of those circuit breakers that we've seen over there, and now sending it to the individual equipment. So for example, this bay right here shows us supplying the 52 volts, about 90 amps of current, and this is one of the other loads here. And so all this panel does here is supplies it maybe for just this bay down here. And right here is all the circuit breakers for the actual equipment. We have voicemail circuits. What else do we have here? Just different bays, RR relay racks. So these are the different bays with different equipment in them. And so right here is, if you were to shut this off here, you would shut power off to whatever piece of equipment this thing was powering. And here at the very end of the run is the power that enters a piece of equipment. The black and red wires on the left side. So unlike a house, it's a little bit more complicated when it comes to central office power. Same thing in a data center. Data centers, some do use DC power, otherwise they use AC power. But that is pretty much how we get power from the incoming circuit panel to the rectifiers to this guy over here. So hopefully you liked this video and found it interesting, and if you did, go ahead and check out some of our other videos that we have. Until next time, thank you for watching.